So an angle bisector is a concept that we should be familiar with. An angle bisector is a ray or a segment or a line that divides an angle into two congruent pieces. So this orange ray is the angle bisector. It is dividing this big angle into two congruent pieces. So this angle and this angle should be the same measure. They should be congruent. The way that we indicate that two angles are congruent is with curvy lines. So angles that are congruent are going to have the same number of curvy lines. So the angle bisector theorem says that if something's the angle bisector, we can pick a point anywhere on the angle bisector, and it is going to be equidistant to the sides of the angle. So first off, the distance between a point and a line is the perpendicular distance. So the shortest distance between a point and a line is the perpendicular distance. So don't let that right angle there really throw you off. It's just trying to show you that this is the shortest distance. But if you pick any point on this angle bisector, it's going to be equidistant to the sides of the angle. So this little nugget would be congruent to this little nugget. And vice versa. If we have an angle and we pick a point on this ray and it's equidistant to the sides of that angle, then we can say, oh, well, that has to be the angle bisector. So, first example, this angle right here, XZY, is 41, the measure is 41 degrees, and the measure of angle XZW is also 41 degrees. So that means that XZ is an angle bisector. That means that XZ is an angle bisector. So that means if I pick point X on that, along that angle bisector, the distance from X to the side of the angle is going to be congruent to the distance from X to the side of the other angle. So if XW is 7, then so is XY. XY is also 7. So XY is 7. Next one, I have point L. The distance from L to side JK is the same as the distance from L to side KM. So notice those tick marks are telling me that this point L is equidistant to the sides of that angle. So that means that KL is the angle bisector. So if KL is the angle bisector, if this little nugget's 37 degrees, then so is this little nugget. This is 37 degrees right here. So they're both 37 degrees. So the measure of angle JKL is 37 degrees. And then finally, right here, this little curvy and this little curvy are telling me that this bad boy JS is the angle bisector. JS is the angle bisector. So that means that if S is a point on that angle bisector, it's going to be equidistant to the sides of the angle. So that means that MS and SP are going to be congruent. So I can set them equal to each other. 3x plus 5 should be equal to 6x minus 7. So I'm going to subtract 3x from both sides. 3x minus 7. I'm going to add 7. Is 12. And then I'm going to divide by 3. So x is 4. But it wants me to find the length of SP, so I got to go plug it back in. 6 times 4 is 24, and 24 minus 7 is 17. And we can verify that we did that correctly by plugging it in for MS. 3 times 4 is 12. 12 plus 5 is 17. They're the same because they're congruent. So the big idea is if you have an angle bisector, so you either are given the angle measures and they're the same, or you see little curvies that are telling you that that ray is dividing that angle into two congruent pieces. If you pick a point on the angle bisector, it's going to be equidistant to the sides of the angle. So this distance and this distance are going to be congruent. They're going to be equal distances.